So this is Combinatorics Lecture 3. And so can everyone see my screen? Someone please respond.
Yeah.
All right. So yeah, so this is the third lecture of Combinatorics and also the final lecture. Sorry. Yeah, this is also the final lecture on Combinatorics and the fifth lecture of this class. So today we'll be going over Markov chains, geometric counting, generating functions, and Catalan numbers. Yeah. And so, yeah, so first of all, does everyone here already know what Markov chains are? Does everyone here already know what Markov chains are? If I don't get a response, I'm just going to assume that all of you do.
Check your chat message.
Okay. Well, so, okay. Well, if you don't know, well then, all right. So, do you know what the concept of states is in combinatorics? Okay. So I'll basically explain that a bit quickly. So I'll just use an example of 4 coin flips. Sorry, that's a bit too long. So for a basic states case, it would be just you're flipping a coin, and so you want at a streak of 2 heads. And when I say streak, I just mean 2 heads in a row. So basically, at any point, the previous 2 coin flips are either tails, 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 heads, or heads, tails. And well, if it goes, it can go to heads, heads, but the moment it does, it's just 0. And so, well, Markov chains and states are basically the same thing, but like Markov chains is basically like you can think of states as you can think of Markov chains as what you use to solve for problems with states. So basically, these are the possible states, these 4 cases. And so what a Markov chain is basically, it basically tells you something like, so for GT, it will return with probability 1/2, or will go to TH with probability 1/2. TH will go to HH with 1/2, or I believe HT with probability 1/2. And you can figure out the rest because it really shouldn't be too hard. I believe HT goes to TH and TT, and HH won't go anywhere because that's already the ending. So yeah, and so basically Markov chains is basically like using the fact that the expected value or probability, it depends on which one, but it works for both. So this it would be a probability. So basically the probability of TT, the probability of TH, the probability of HT, and the probability of HH. And they can use the fact that these 4 are interlinking to each other to set up equations and solve. And so that's basically Markov chains, and yeah, that's basically what a Markov chains are. Do you still need to see that actually? Oh. Well, there's no undo button, so yeah, sorry about that. Okay, want HH. Alright, so yeah, so the states are TT, TH, HT, and HH. Alright, I'll make this look neater then. So for TT, it can go back to itself with 1/2. TT can also go to TH with 1/2. TH will go to HT with 1/2, and HH with 1/2. HT will go to TH with probably 1/2, and TT with 1/2, and HH just goes nowhere. And so basically P of HT, P of HT, P of TH, P of TT. Actually, I'll just give you the equations for this. So basically in here it will be, I believe, P of HH is 1/2 P of TH. Yeah. And P of HT is 1/2 P of TT. And I believe that is it. And then P of TH is 1/2 P of TT is 1/2 P of HT. Okay. P of H plus 1/2 P of HT. And this is just 1/2 of PTT plus 1/2 PHT. And so yeah. So basically Markov chains are basically the method for setting up this equations, and then you can just solve these equations. So yeah. All right. All right. At any rate, I'll just start going over this problem now. So I'll just erase this part. This is probably a rather sloppy introduction to Markov chains, but can't do much about that. All right. So P let P be the probability that in the process of repeatedly flipping a fair coin, one will encounter a run of 5 heads before it encounters a run of 2 tails. So given that P is of the form over N, we want to find N plus N. So yeah. So after we flip one coin, so let's the desired probability P be P1 if the first flip it lands on tails, and P2 if the first flip lands on the heads. And so then you have that is equal to P1 plus P2 over 2. And that's just because it's not really their average, but more accurately, each of these is, each of P1 and P2 occur with probability 1/2. Although in the end, it's really the same thing. And so now we have some, and now this creates some more equations. And so we get that. Sorry. So if a tail is flipped, then so for the event to happen of 5 heads before a run of 2 tails, that means that if a tail is flipped, then the next it must be a head. And so that just goes P1 to P2. And so that means that P1 is equal to 1/2 of P2. And so for P2, if 4 heads are flipped in a row, then it will happen. And otherwise, the most recent flip would be a tails. Because if a streak of heads is stopped, the one that stopped it must have been a tails. So, yeah. So that means that P2 is equal to 1/16th, the probability of just straight up finishing, plus 15/16 times P1. And so you can just substitute this to get P2 is equal to 1/16th plus 15/32 P2. And so that would just mean that P2 is equal to 2/17 and P1 is equal to 1/17. And so we want to find P, which is the average of P1 and P2. So P is equal to 2/17 plus 1/17 over 2, or 3/30. And so we want to find n plus n. So this is just 0.37. So does anyone have any questions regarding this problem? And if so, please ask them. And if not, you can move on to the next one. And once again, if you have any, and as usual, if you have any answers, please just private message. All right, well, I'll start going over this problem now. So Rosencrantz and Guildenstern are playing a game where they repeatedly flip coins. So Rosencrantz wins if one head and 2009 tails appears, and Guildenstern wins if 2010 heads appear in a row. So find the probability that Rosencrantz wins. And so first of all, note that throughout my entire solution, I am simply abbreviating the names to R. I don't think I've ever used she. So yeah. So first of all, what we do is assume that the first row is a hex. And the reason is because if it were tails, then nothing happens. Because it won't affect either of them. Because both of them need to start off with. So just assume that the first one is a hex. So now the x is the probability that Rosencrantz wins, and the y will be the probability he does so after he does win after an HT is rolled. Sorry. So if the string of T and the tails is less than 2009, then we can just reset back to the beginning. So you have x is equal to y times 1 minus 1/1 2 to the 2009. And the reason for this is because for the initial heads, there is this much of a probability that Rosencrantz does not lose. Oops. Okay, yeah, sorry. So there's that much of a probability that he will win. And the last two flips are HT, in which case Rosencrantz has a probability Y. And so if the first pair lands on HT, whoops. The first hit lands on HT, then we can see that the probability for Rosencrantz to win is 1/2 to the power of 2008. And if not, then we just loop back. And then, yeah. And so eventually, this just means that you get that y is equal to 1/2 to the power of 2008 minus x, sorry, plus x. I don't know where the other part of it is. plus x minus 2001 minus x times 1 minus 2 over 2002 to the 2008. And so that will imply that this equation is true. And so we can really just solve for x. And we can see that x is equal to 2 to the power of 2009 minus 1 divided by 2 to the power of 2009 plus 2 to the power of 2008 2009 versus this go with 3 times 2 to the power of 2008 minus 1. Oh yeah. And so that's it for this question. And so are there any questions? And so please, if you have any questions, please ask and make sure you let me know. And otherwise, we are moving on to the next question. And our next unit, which is geometric probability. Geometric probability is basically where you use a graph, where you take a graph and you turn it into and you somehow project that graph onto combo. Alright, so I'll start explaining this problem now. So we have a polyhedron such that an ant takes off from one vertex to another, traveling along all the edges and traveling across each edge exactly once. And so we want to find the smallest possible sum of the vertices, edges, and faces of this polyhedron. So it will turn out that the answer is 1. And so one possible way to construct this is like this. So yeah. And in fact, this kind of path has a special name, and it's known as a Eulerian path, and there's a lot of special properties. So if you want, you can check out more about this, but that's not very important for now. So first of all, the number of vertices is at least 5, and that's simply because if it were 4, then the polyhedron would have to be a tetrahedra, but tetrahedra do not have such paths, and that's simply just won't work because of how tetrahedra are shaped in the first place. And one of the important reasons for that is because at most 2 vertices will have an odd number of edges in any graph of such paths, no matter 2D, 3D, 4D, whatever. And the reason is because there's for each edge, for each vertex, there's always one edge going in, and there will always be another edge going out. And the only time there will be an odd number is if there's no vertex going in on the first vertex, and no edge going in on the first vertex, and no edge going out on the last vertex. So those are the only 2 where it's possible to have an odd. And even then, there's sometimes even. And so that means that the number of edges is at least 3 plus 3, and then the rest have to all be even. So they're all at least 4. So we just have 3 plus 3 plus 4 plus 4 plus 4, and all divided by 2. Because this is the number of edges summed over the number of vertexes, but at the same time, this is the number of edges that count from each vertex. And so, yeah, this is the number of edges that we count by summing the number up from each vertex. And we need to have this, because otherwise it will just not work. Sorry, it's not that no. Sorry. Sorry, it's just that you're double counting because each edge goes between two vertices. And so now if f is equal to 4, then that would imply that all faces are triangles. And so that would be another tetrahedron. But as stated earlier, tetrahedra will all fit. So that means that f is at least 5, and so f plus b plus e is at least 19. But Euler's something. I think it's Euler's theorem or formula. Something along the line of that. There's so many. Anyway, so one of them basically states that the sum of the faces plus the vertices minus the number of edges of any 3D shape is equal to 2. Actually, I don't know, but this might hold for higher dimensions as well. But either way, it works for 3D, which is what is important here. So the faces plus the vertices minus the edges is 2. And so that would mean that the faces plus the vertices plus the number of edges is 2e plus 2, and that is definitely even. And so that would imply that our answer is 20. And because it's at least 19 and it must be even, so it must be at least 20. And we have already shown up here that 20 works. So the answer is 20. And so if you have any questions, feel free to ask. And if not, let's just move on to this question. And once again, if you get any answers, please private message me with an answer and so on. Okay, yeah, so I'll start explaining this now. So before this, I also want to quickly skim over what a generating function is. So basically, let's say there's a sequence A1 equals 1, A2 equals 5, A3 equals 7. Okay, A3 equals 3 now. A4 equals 2, A5 equals 6. There's no pattern here, it's just random numbers. Then the generating function of this would be, also let's set A0 to be equal to 8. So the generating function of this would be 8 plus 1 times x plus 5 times x squared plus 3 times x cubed plus 2 times x fourth and plus 6 times x fifth and so on. So yeah, the generating function basically is like this. And at the same time, all properties that hold true to functions also hold true for generating functions. So yeah. So now let's start the problem. So there are 7 teams playing a soccer tournament, and each team plays every other team exactly once. No ties occur, and each team has a 50% chance of winning each game it plays, and the outcome of the games are independent. And in each game, the winner gets a point and the loser gets none. And so the total points are accumulated to decide the ranks of the teams. So we're given that in the first game, Team A beats Team B. We want to find the probability that Team A ends with more than Team B in terms of points. So yeah. So the generating function for B would be, so for the first game, it would be 1 plus 0x to the 1, because it's guaranteed that B loses. So this 1 point possibility here, represented by x to the power of 1, has a coefficient of 0. And for the rest of the games, it's all just 1 plus x. And there's a total of 5 other games. Because that's the number of teams minus A minus B. So yeah. So now the generating function for team A is almost the same, except it's now 1 times x to the 1 times 1 plus x to the power 5. So now we just expand this out if we want. And so what we get is that this is 1 plus 5x squared. Sorry, not 5x squared. 1 plus 5x. The 1 plus 10x squared plus 10x cubed plus 5x to the 4th plus x to the 5th. And this is just x times that. So 1 times x to the 1 plus 5 times x squared plus 10 times x cubed plus 10 times 10 times x cubed plus 10 times x fourth plus 5 times x to the 5th plus x to the 6th. And so the probability that B wins the probability that B wins 0 games is 1 over 32. And the probability that A wins more games will then be 32 over 32. Because that's just literally this compared to this. And so we can just continue checking this one by one. So 5 over 32 times 31 over 32, 10, 32 times 26, 32, over 32 times 16 over 32, 10 over 30. Sorry, not 10. This is a 5. 5 over 32 times 6 over 32 and 1 over 32 times 1 over 32. And this is equal to 638 or 1020, which is 319 over 512. And so we want to find n plus n here. So what we get is that the sum is simply 830. So that's the answer to this question. So if there are any questions, please ask. And if not...
Wait, isn't it 831?
Sorry. I wrote this in the wrong. 831. Yeah, sorry about that. Well, then other than that, so are there any other questions? Okay, well, there's not much time left, so I'll just skip the next one and just move on to this last question. So, yeah. Actually, do you know what the Kylan numbers are? All right. If you do know them, then that's good. All right. So I'll quickly start going over this. So a subset is called, of the non-negative integers, it's called supported if it has 0. And for every k plus 8 and k plus n are in S. Let's we want to find the number of supported sets. Hold on for a second. Okay, sorry about that. So basically, you can see that every support set has to have 0, so also has to have 8 and 9, and so also have 16, 17, 18, and then 24 to 27, 32 to 36, 40 to 45, and 48 to 54, and then every number above 55. And so now we look at it. And so now we look at, sorry. So we can just make a new set S. I'm not sure how to read that, but conjugate of S, and such that it's basically the positive integers minus S, or basically all elements not in S. And so it has to be a subset of the numbers of 1 to 7, 10 to 15, 19 to 23, 28 to 31, 37 to 39, 46, 47, and 55. Yeah. On here, this should reach 56. Actually. So yeah. And so this satisfies the property that for any k in S conjugates, then basically for any k in S conjugate, then k minus 8 and k minus 9 are in S conjugates. So now we look at a grid that looks like, not grid, but like a triangle or tree, whatever you'd want to call it. So I'll just draw it out. So 55, 46, 47, 37, 38, 39, 28, 29, 30, 31, 1, okay. And then 19. I should have just fill out this first. I don't know first. 19, then 20, 21, 22, 23, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7. Oh, okay. And so now we want to add a few more dots here. And I'll explain what the point of these is in the short. All right. So what you can do is call this 16,0 and call the one here. I hope you'll know what I'm referring to. 0, 0. All right. So yeah. So now we look at this arrangement. And so what we're removing are the numbers that are not in S. And so the condition that S is supported ensures that, sets S prime, S conjugates correspond exactly with the paths from 0, 0 to 16, 0 that consists of paths of +1, +1, S plus 1, plus 1, or S plus 1 and n minus 1. The paths made up of entirely these two moves and lie entirely above the x-axis. And so that just means that the answer is just C8, or the 8th Catalan number. And so generally you can memorize a few Catalan numbers, but most people won't remember up to C8. So what you instead use is the formula that that Cn is equal to 1 over n plus 1 times 2n, choose n. And so here it would be 1/9 of 16 choose 8, which if you calculate this out is 1,430. So the answer to this question is 1,430. And so yeah. So are there any questions for this? Okay, so yeah. So last call for any questions for anything? Okay. Well, I guess there are no more questions, and so yeah, that was the last problem for today. And so thank you for coming, and I hope all of you have a nice rest of your week. So thank you and bye.